This is conditional probability number 2, where we take the ideas a little bit further, and in our previous video we looked at the probability of A given B is the probability of the intersection between A and B over the probability of B, provided probability of B doesn't equal 0. This is conditional probability, as we saw previously. We can rearrange the formula, and it's actually called the multiplication rule of probability with a conditional situation. In a conditional situation, this is our multiplication rule. So we're not talking about independent events. Independent events are treated separately in a different video. Okay, so we have a conditional situation. So you can see that this formula here is a rearrangement of the one above. Now, another thing I'd like to point out, which will become useful soon, is that the probability of A intersection B is the same thing as the probability of B intersection A, because if we draw a Venn diagram, it's the same zone. So if we have sets A and B, regardless of whether we call this one A or B, likewise that one, the intersection is there. So it's both the same. So you can switch those around for the intersection. It means the same zone. Looking at a fairly straightforward example now, we've got 500 people surveyed, and basically they're classified into two age groups, younger than 25 and 25 and older. You can see that there. The results of the survey are shown below. The task: if a person is randomly selected from the total of 500, and given that the selected person is younger than 25, what is the probability that they regularly use YouTube? Okay, so survey about YouTube, 500 people, given that they're younger than 25, what's the probability that they regularly use it based on this data here? This is a straightforward use of the formula for conditional probability, so we'll write it down. Probability of A given B equals the intersection, or the probability of the intersection, over the probability of B. Now we just need to identify events A and B. So let's define the events A and B. So write those down there. The word given, to my mind, is a bit of a hint. So given, look for that word, given that the person's younger than 25. So that gives us an idea about, remember the format is A given B, so B is the younger than 25 years old. Okay, so that's event B. So event A is they regularly use YouTube, and if you look at the table, that would be in the yes. So in other words, it would come up as a yes. So you need to define clearly the events, what you're looking for. Then it's a pretty easy case of substitution here. So let's do that. So what is the probability of B? So the probability of B being under 25 is 240 out of 500. So 240 over 500. And what's the probability of A intersection B? Well, that's regular uses under 25, so that's in the yes, and under 25 there's 200 over, again, 500. So 200 over 500. Now you could go and calculate that, but really when you put these into the main formula over here, you can see the 500s, it'll be 200 over 500 over 240 over 500. The 500s will cancel. So it's really just, because it's got the same total for each probability calculation, we can just use the number of each, provided we substitute it correctly. So it's 200 over 240. Oops, 240. There we go. And we can cancel that through. It's 10 over 12, 5 to 6. Simplify. Final example, given that for two events A and B, probability of A is 0.7, probability of B 0.3, and probability of B given A is 0.4, find the intersection of probability of the intersection A and B. We need to write down a formula that hopefully involves all of the given information. Now, a little trick here, and it alludes to what I mentioned earlier in the video. We can write probability of A intersection B as probability of B intersection A, because remember, it is that shared overlap, so it, like I showed you a minute ago, it's the same result. So let's see what we can do here. Wouldn't it be the case that the probability of B given A equals the probability of B intersection A over the probability of A? So we have those things. Once we do a rearrangement, we're chasing probability of B intersection A. So I'm just doing that rearrangement like I showed at the start of the video. Probability of B given A, which we have, times the probability of A, which we have. Multiplication rule that we looked at the start of the video. That is 0.4 times 0.7, 0.28. So for the next part, probability of A given B, notice how they're not the same, alright, and we've established that in our previous work. These here are not the same. It's quite clear once we investigate that, and we've looked at that in the past. So probability of A given B, let's see if we can write a formula out for that. That is the probability of the intersection of A and B over the probability of B. And hopefully we have all those things. Let's have a look at that. Do we have the probability of B? We do, it's 0.3. Do we have the probability of A intersection B? Yes, we do, because we said those are the same, and we've got those there because we found that in our previous work there. So that's 0.28 over 0.3. You can write that as a decimal, or you might be able to use your work with fractions to come up with a nice elegant fraction. How about 28 over 30? Which is 14 over 15.